We're going to be solving questions today using proportional reasoning, and the method that we'll use is looking at a table of values. The overall expectation is solving problems involving proportional reasoning, and our specific expectation is to illustrate equivalent ratios using a variety of tools. And in our example is a table of values. So let's go to our question here. We'll read the question once over, then we'll highlight important information and come up with a method to solve, in this case using table of values. So the table below shows, so this is our table below, shows the cost of water for 3 different customers. So we have customer, maybe we'll label it. Actually, let's, like we said, read it through first. They pay the same cost per liter. And here's our question. Gabriel pays $46 for water at the same rate. Determine the number of liters of water that he purchased. So, important info. The table below shows the cost of water for 3 different customers. So each of these is a different customer, and they each pay the same cost per liter. So we know that the rate is the exact same. Here's our table. We'll call this customer 1, customer 2, and customer 3, all paying the same rate, and we'll check that. The question says Gabriel pays $46 for water. That's important. He pays $46 for water, and it's at the same rate. Determine the number of liters of water that he purchases. Okay, could quickly use a calculator and make sure that these are all the same rate. They've said it, but it's always good to check these types of things. So, and you can really choose to divide amount by cost, or you can do cost by amount. They'll give you a value, and as long as that value is the same for each of them, then we know the rate they're paying. So in this one, I'm going to divide cost by amount. So $9.20, or 9.2. You can add the 0. It's irrelevant for the division. Divided by 10,000. Okay, so here's our value. You might want to write this down. Luckily, my calculator has different lines, so I'm going to do customer 2's rate. 4 divide 20,000, exact same value, and 27.6 divide 30,000. Look at that. They all pay the same rate. Good. So we checked that. That was just a check. Luckily, in this question, they already have a table of values for us. We have our amount in liters. Okay, here's our amount in liters, and they've written it for us, and the amount we pay, okay, right here. So what we're going to do is we're going to continue this table of values down. In fact, what I'll do is I'll copy it, and I know you guys don't quite have this privilege, but let's copy it. I'm going to paste it below so I have some room. There we go. And we'll continue the table like we said. So I'm just going to extend this line here, and we're going to build some extra rows. And we'll always have our 2 columns, okay? Now these are the first 3 customers. What we're going to do is we're going to increase the amount of liters they're purchasing at the same rate it was going up by. So in order to figure out what it's going up by, we should really take the second value and subtract the first one. And do that for the third value, subtract the second one, just to make sure the rate it's increasing by is the same. Okay, so if I take 20,000 and we subtract 10,000, most of you know that we'll get 10,000. And then if we take our 30, actually let's write that in first. So what that meant was this was increasing by 10,000. I use a plus sign to say increase. What is this increasing by? Let's check. 30,000 subtract 20,000. Hopefully you guys know this, that this ends up being 10,000 again. Great. So it's increasing at the same rate. So again by another 10,000. I'm going to write it on this side now. So let's increase by another 10,000. So 30,000 plus 10,000 would give us, in liters, 40,000. Okay? We'll continue the table. We again increase by 10,000. That puts us at 50,000. And we increase it one more time by 10,000. That puts us at 60,000. Well, what we're going to try to figure out now, so I've increased the amount of liters. And remember, that's the goal in this question. How many liters did Gabriel purchase? Well, here's our dollar amount. We're going to increase the dollar amount, and we're going to make sure it's increasing by the same amount, which it should since the liters are increasing by the same amount. We're going to go and increase the dollar amount until we find a value where $46 either exactly is, maybe it's one of these exact amounts, or it's between here. Okay, so let's check what it's increasing by. In order to do that, we'll take our second value here, so our 1840, and we'll subtract our first value. So 18.40 9.4 subtract 9.2 equals 9.2. Okay, good to know that this increased by $9.20. Okay, and then we're going to take this and see if this rate is the same again. So this time we'll take the 27.6 and subtract the 18.4, and lo and behold, $9.20 again. Great. So just as the liters increased by 10,000, we knew that the dollar amount increases by $9.20. So we're going to do the same thing. We're going to add $9.20 throughout our table to see if we end up at exactly where Gabriel had spent his $46. Okay, so we're going to keep increasing. I keep adding using the addition sign for increasing. So we had 27.6, and we're going to add our $9.20, $36.80. Okay, so we have $36.80, and that's for 40,000 liters of water. Let's take this amount again, $36.80, and we're going to add $9.20 again, and we get $46. We got that $46 when we added this together. $46. We can put our 2 zeros for our cents. Excellent. And finally, we should increase it one more just to complete our table, though many of you may have realized that we might actually be done at this point. Let's take our $46 and add our $9.20, and that gives us $55.20. So we will write that in, $55.20. Well, as we completed the table, you may have noticed that we've already figured out exactly what we needed to know. Gabriel had spent $46, and it turns out that means he purchased 50,000 liters of water in this case. Okay. So, if you'd like to figure out other ways to solve this question, you can check out our other playlists for different methods of solving the same question.